Hey everyone, I'm James, CTO and founder of Ezbot. I've been working in data engineering and machine learning ops for more than 10 years. My friends and I started Ezbot to solve a problem. Finding a user experience that works is hard. We use deep reinforcement learning to make this user experience optimization process easier than ever. Today, I'm here to tell you a little bit about how Ezbot works. So to understand Ezbot, it helps to start with A/B testing. What is A/B testing? Well, we have a website. Let's say we sell widgets. Maybe when somebody gets to our website, they've got a newsletter pop up. They have a butter bar at the top. A butter bar is a little strip that says 30% discount on blah, blah, blah. And their add to cart button is red. Now, we don't know that's the best user experience. We don't know that that discount in the butter bar or the newsletter pop-up or the color red on the add to cart button are actually the best for users. The state of the industry today is to do an A/B test. Let's take the red shopping cart button, for example. We want to see if we can have a better color for our shopping cart. Is blue better than red? Is purple better than blue? What we do is run an A/B test. We show part of our users version A, and we show the rest of our users version B. We collect statistics about all of their sessions and whether or not they completed a purchase of a widget, and then we can tell red was better than blue. It works great. It's definitely the standard in the industry. Let's talk about a simple e-commerce company who wants to A/B test. Let's say they have 20,000 monthly visitors. If you're not familiar with the term, a user converts on a website when they complete some action. So for e-commerce, it might be purchase, it might be signing up for a newsletter, it might be booking a demo. In this case, we're gonna stick with that e-commerce example. A user converts when they buy something. Conversion rates vary a lot by industry, but assuming a 2.5% conversion rate is okay for general e-commerce. For 20,000 monthly visits, we only see 500 sales. The first problem this causes with A/B testing is speed. In this example, even if version B is 12% better, due to the nature of statistics, it's gonna take us 2 months to find out if version A is better than version B. If there's only a 5% difference between B and A, we have to collect more data than if there's a 80% difference between B and A. It becomes obvious much more quickly. So A/B testing is slow. You don't always know how long you're gonna have to run a test for, and depending on what order you test things in, it can take a long time to find the best option. The nature of the statistics is that the lower our conversion rate, the longer our experiments have to run. The second problem with A/B testing is that it gets complex really fast. You have to be an experimental designer. You have to know what a control group is and a treatment. You have to know how to collect statistics and interpret statistics. And you have to know p-values and how to determine statistical significance of your test. This is pretty unreasonable for any old e-commerce store owner. The best we've heard is running a Google Calendar, checking their own Google Analytics to see, okay, this month I ran this headline, next month I'll run the next headline and see if it does better. Well, that's great, but that's really hard. That's really complex at the small scale. At the top of the spectrum, enterprise companies, they have multiple experimentation teams with top of the line A/B testing tools, and it's still complex to manage experimentation. There's so many experiments to run, so many places and so many products. If you leave your experiment running too long, or even forget about it, you're eating up some of your traffic that you could use to gain valuable information. There's another thing called interaction effects that makes testing multiple things at the same time even more complicated. Typically, you're trying to isolate one test from another. There's many ways to do this. People normally carve their traffic into smaller chunks. They allocate some traffic over here for this experiment and some over here for this experiment, typically managed by different people. In that competitive environment, managing the traffic, allocating it to one experiment or another, to one team or another, is difficult. Another one is multivariate testing, where you can do some advanced statistics and extract interaction effects from one variable on another. It's complex to manage. There's still a lot of human decision making involved in what gets tested and when, and that makes a lot of opportunity for bias. Humans have to artificially select what UXs they're testing and limit the number that they test. The third problem is cost. For the teams that are able to afford experimentation tools, they are expensive. Not only in terms of the tool itself, but the number of expert statisticians or experimental experts you have to hire to run the tool. When you hire so many people, the ROI is questionable. So how is Ezbot different? What are we doing that's different than A/B testing and experimentation? We fundamentally saw this as a different problem. Our goal is to recommend the best user experience for each person. Our goal is to get the most value out of the traffic that visits your website. To do that, we use deep reinforcement learning, and that has some advantages that I'm going to go over next. The first is sample efficiency. Traditional A/B tests have poor sample efficiency. This means they need a lot of data to be able to understand anything about what's going on. A lot of deep learning techniques, while computationally intensive, require less compute power than traditional statistical or Bayesian techniques. So our deep reinforcement learning model gives us much higher sample efficiency. This means we're able to learn with far less data and get far higher results in a shorter amount of time. We can evaluate more experiments with less traffic. The second benefit of going with a deep reinforcement learning approach is that reinforcement learning fundamentally solves this problem with agency. So how does that work? Normally, with A/B testing, humans have to monitor. Have I collected enough data? Can I end this experiment? Is there statistical significance? Tools present data to them, but they must still do the decision making and interpret the results. If you're running a good experimental program, a lot of those results should be automatable. So what if our AI could see the results changing and automatically adapt? As soon as Ezbot detects top performing variations, it's going to start promoting them and showing them to more users. Conversely, if we see something is performing worse, maybe there's a bug or you're not even able to check out, we can serve that variation less and less over time. This helps manage risk automatically and helps maximize the value even before we can conclude an experiment. Ezbot's deep reinforcement learning also takes in interaction effects. This means we're able to holistically optimize the entire user experience. We're also able to take user context into account, what page they've landed on, what time it is for them, maybe even what time of the year it is, to provide them a better user experience that matches what they're looking for. So that's why Ezbot started exploring deep reinforcement learning to solve this problem. We wanted to use the sample efficiency to learn more faster, and we wanted to use the agency of reinforcement learning to automate all the decision making and reduce complexity. So how exactly does Ezbot work? The first stage of any AI is data collection. Without data, we can't really do anything at all. At Ezbot, our customers install software similar to Google Analytics that allows us to understand how users interact with their website. This user viewed this page, clicked this link, the next page, they added a product to their cart, then they checked out. We get small little events, little breadcrumbs as they travel through your site, and that helps us put together a bigger picture of their overall session. The next step after data collection is data enrichment and feature engineering. Enrichment's pretty simple. There's a lot of ways we can look up additional information, maybe approximate location from IP address, maybe we're just stripping UTM parameters, maybe we're splitting apart a user agent into more digestible chunks. So enrichment really just makes the data easier to use and prevents us from doing joins in the future. Feature engineering is how we make the machines understand our data. So most machine learning models only work on numbers between -1 and 1, and this creates some interesting challenges. Let's say, for example, we want to tell our model something about the time, like it's 3:30 a.m. We use a little bit of trigonometry. So we can take the time and imagine a unit circle. And as we go around the unit circle, we start at midnight and then go to 6 a.m., 12 a.m., 6 p.m. Now each time is going to be represented by a vector on the unit circle. 3:30 a.m. is going to be somewhere like this. And now we can project that using sine and cosine onto the x and y axis. And we have two numbers between -1 and 1 that a machine can understand. This feature engineering is a really creative process. There's a lot of ways to join data together or transform it to create values that machines can understand in more nuanced ways. Let's go back to that data we're collecting. We have little breadcrumbs of how a user traversed through a website, and we need our machine to understand, did this user convert or not? But more than that, we'd like our machine to score each session. Even if a user doesn't purchase something, that session was still valuable. If they added several products to their cart, interacted with some comments, read some reviews, that's still a pretty good session in terms of user experience. At Ezbot, we use our feature engineering to reshape the data in such a way that we can let the machine learn the value of each session. So we're able to score every single session that happens, not just the ones that convert. This is one of the ways we get extremely high sample efficiency, orders of magnitude better than traditional Bayesian methods. Now let's remember our goal again. When a user lands on a customer's page, our goal is to predict the best user experience for them. Now to do that, we need to have a model. The training process for reinforcement learning is deceptively simple. So in reinforcement learning, we typically need at least 4 pieces of information. We need some state. The state represents what we know about the world. In Ezbot's case, that's that user's contextual information. The next thing we need is an action. The action is what our model chose to do. So we have a state, an action, and a reward. The reward is where we come back to scoring a session. In the simplest way, a conversion is a reward of 1, and a non-converting session is a score of 0. There's many other ways to model reward. And then we finally need a new state. Where did we land? So once we have that information, a state, an action, a reward, and a new state, we can train several neural networks that all help each other out to create one final model that takes the user's context, the state, and predicts the best action. Ezbot saves these as a checkpoint. We're using a product called Ray. It's the same training framework that OpenAI uses to scale their machine learning. These checkpoints are very small, very portable, and let us run as many predictions as we need in parallel. We can also take these checkpoints and evaluate them against the model that's running in production. This ensures we're not promoting new models that are worse performing than old models. Now that we have a model checkpoint that can take a user context and predict the best actions, how do we turn that into a prediction server? Number one, before we have a model ready, Ezbot has to serve data randomly. After that random serving, when we train the first checkpoint, from then on, everything is predicted. So Ezbot's traffic is going to start off random, but rapidly, as it gets new checkpoints and collects new data, its performance is going to improve. Now that checkpoint does something interesting. It doesn't just predict the best possible user experience. It predicts the value of each user experience. If we always select the best user experience, we may never learn something new. We may never realize that for this user, there's a better option, or that this experience that people haven't seen yet is really going to perform quite well. This is commonly known as the exploration-exploitation trade-off. There's deep research into this area. Ezbot has a little bit of secret sauce. Suffice it to say, it's similar to how OpenAI makes their words more or less spicy. The real power in Ezbot is that this whole process repeats constantly and forever. As we get new data, as seasons change, as preferences change, Ezbot adapts, updates, and continues finding the optimal experience for your website. We're continuously collecting new data, continuously improving our models, our user context, our explore-exploit trade-offs, constantly optimizing your website each and every day. That's it. Thanks for your time, everyone. I'm James with Ezbot, and remember, just try it.